Alright, hello, welcome back to A Software Engineer Plays, the channel where a software engineer, that's me, plays through games designed to teach you logic behind programming. We're back in Human Resource Machine, and let's jump right in. So last time we talked about the modulo operator. This time we're going to talk about level 26 here, called Small Divide. I'm not really sure what we're going to be getting into from the room name. I'm guessing some kind of division, but I'm not really sure what the small part means. So let's jump in and see what we're supposed to be doing here. Okay, so you don't need to divide. Now you get to. Okay. How many times? Oh, okay, so we're doing essentially the opposite of the mod. Well, not the opposite. The complement to the modulo operator. So we're doing the divisor, and we do not need the remainder. It's telling us to try copying and pasting from a previous assignment, so I'm guessing the result is going to be very similar to the modulo operator, but let's think it through. So I think we're going to need to use 0 as a counter, so we'll call this counter. So we'll start off by copying from 0 and copying it to counter. Then we can inbox and put it in 0. We'll call this one A. And if we learned anything from the last video, it's that we don't really need to store the second number. Thinking about it though, I'm not so sure. We'll go ahead and copy it to B here. Alright, so now we want to pick up A and subtract B. So copy from A and subtract B, and then, so in this case we'd have 6, 4, we'd subtract it, and then we want to bump up our counter. But before we do that, we want to check to see if the result of this is negative, because if it's negative, then we want to start all over again, or we want to outbox rather. Otherwise, we want to jump up to that and keep subtracting B, and then we copy from counter and send to the outbox. So, stepping through this, we initialize our counter to be 0, set up our two numbers here, and then we're going to keep subtracting B from A, and incrementing our counter every time the result is not negative. If it is negative, and presumably also if it's 0, we want to then jump out and move the counter to the outbox and then start over again. So this should work, but let's run through it and see how that all shapes up. Okay, so now we're going to start doing the subtraction process, and it's not negative, so we're going to go 1, bump up the counter. Okay, so I see a problem, and that problem is that we've got 1 in our hands now, so we are going to need to pick up copy from A every time through the loop. So we'll just move that up 1 step so that we always get a fresh copy of A. But we are going to need to store the result in A after subtracting B as well, so there we go. Let's try this out now. So we'll initialize our counter, put 9 in A, put 2 in B, and then start the process here. So we end up with a 7. Now we keep on going. Now we're going to get a 5. Keep on going. And a 3. going to become 4. So 4 is the answer that we expect now. And we get a -1 here now. So we're going to jump out, copy from the counter, and outbox. So that looks like it's working. The next case we should end up with a 0 as our last step here. So we reinitialize our counter, because 8 divided by 2 is going to be 4 with no remainder. So we should get 4 and have a 0 and A at the end of the loop. So let's see how that works out. Okay, this should be our last iteration through here. End up with 0, and then because it's 0, okay, so that's because it's 0, we skipped our last bump. So we want to add. That's not. I don't think we need the jump if 0 here, so we'll remove it. And we'll see what happens on our second loop through here, so we'll just speed up through there. Okay, so now we'll start again. We get 6, we get 3, do 1 subtraction, get 1, do the second subtraction, get 0, so that's the 2, and now we're going to get a -3 here, and we will outbox the 2. Okay, so that's now working as expected. So let's zoom through the rest of these examples and see how it works. It looks good, but how do we do performance-wise? We did it in 15 steps, and... okay, 80 steps, so we should be able to, speed this up by doing the subtraction multiple times in here. So let's see if we put a copy from A, sub B, copy to A, put another jump if negative in there. It's not pretty, but it should work. Let's see if it speeds things up. Okay. I forgot an all-important statement in my haste. I forgot a bump on the counter, so let's try it again. That's what I get for trying to be speedy. How did we do? Did we save those additional 4? We're gonna fail there, but I should see a little bit of an improvement here. Whew, so close! Oh, what are the odds? Alright, what else can we do here? I mean, apart from just pasting it in 1 extra time, which could work. It's not super elegant, but you know, elegance isn't always the name of the game. I'm not super pleased with it. There's probably a way we could do it better. Let's see, how do we do? Way over there, and yeah, so you can see the law of diminishing returns in effect there with the number of times we copy and paste that block. Every time we copy and paste it, we're going to see fewer and fewer returns. So the first time we copied and pasted it, we saw a gain of 3 steps in speed, and the second time we saw a gain of 1 step in speed. So diminishing returns, very much alive and well. But we did hit the speed challenge. It's not the most elegant solution, but we did achieve both goals, so I'm going to go ahead and get back to the elevator and say thank you very much for watching. This has been a Software Engineer Plays. If you enjoyed the content, please like, please consider subscribing, and share it with a friend who's interested in the same kind of stuff. So that'll be it from me. Thank you again. Hope you have a great day, and stay curious. Alright, bye.